So for the second one, you can see the x squared, it's the positive one. That means it is a horizontal hyperbola. Okay. So then you have 25x squared minus 100x minus 9y squared minus 72y. It's equal to 269. So just like before, you want to make sure the coefficient of x squared is equal to 1 so that you can complete the square. And same thing for y squared. And this will be a plus 8y equals to 269. And then you will have to add how many? You can add 4. So on the right-hand side, you will add 100. And then for the second one, second pair of parentheses, you have to add 16. Therefore, you have to subtract 144. Okay, 9 times 16, it's 144. I think that's one thing we have seen for a couple of times already. So you have 25 times x minus 2 parentheses square, and then 9 times 8 y plus 4 parentheses square. And when you have 269 plus 100, which is 369, 369 minus 144, it's 225. So to get 1 on the right-hand side, you will divide both sides by 225. So your final equation will look like this. X minus 2 square over 9. And then y plus 4 square over 25. So you know your A value is 3. Your B value is 5. Your center, it's going to be at 2 comma negative 4. Okay. So this one, it's a horizontal hyperbola. Okay. So so you have 2 comma negative 4, 2 comma negative 4 right here. So A, it's 3. So you have the vertices there, left and right of the center, 3 units away. And then the B, it's 5 units away. So you can go ahead and draw the box. And then immediately you can draw the diagonals. Okay, and because it's a horizontal hyperbola, you go ahead to draw the hyperbolas like this. Okay, so make sure that your sketch and the actual graph, they are matched up in terms of orientation. Okay, and then for the vertices, where are the vertices? Left and right of the center, so they must share the same y value. So we have 2 plus 3, which is 5, and 2 minus 3, which is negative 1. The endpoints of the conjugate axis, so they are the points above and below the center. So they must share the same x value. So negative 4 plus 5 would be 1. Negative 4 minus 5 would be negative 9. And c squared is equal to a squared plus b squared. So a squared is 9, b squared is 25. So c squared is equal to 34. So c is equal to square root of 34. And approximately, like what's square root of 34? Around close to less than 6, close to 6, but less than 6. So if you want to draw the focus, okay, again, I can foresee some mistake here. The foci, it's the center plus or minus C units, not from the vertex, from the center. So so here C units, C is almost 6. So I would say this is the focus. This would be a focus as well. Okay, so these two are the foci. And let's go ahead and write down the coordinates here. For the two foci, again, they are the same. They have the same y value, like the center. So -4, -4 for the y value. It is square root of 34 units away. So 2 plus root 34 and 2 minus root 34. The lattice rectum, it's 2b squared over a. So 50 over 3 would be the length of lattice rectum. The asymptotes would be y minus the value of the center equals to plus or minus the slope. And then we have x minus 2. So now we look at the slope of the asymptote. So rise over run. Rise over run. So is it a over b or b over a? So the rise is the b value. So rise is the b value. The run is the a value. So if you think that you might make a mistake, you are more than welcome to actually label your A and B, or even C on the diagram to prevent any sort of mistake. So again, rise is B, run is A. So therefore the slope is B over A, which is 5 over 3. Okay, so that's how you take care of the little diagram like this, with the equation from the general form, working all the way to a standard, drawing diagram, label the A, B, and C values, having the vertices, the box, the asymptotes all together.